Hello, good morning, good afternoon, and good evening. This is Paul Liu from NC State University. Welcome you again to this World Large River and Delta Systems Source to Sink webinar series. Today, we are very honored to invite Professor Robert Nicholls from Tyndall Center for Climate Change Research, University of East Anglia, to give us the talk. Title is Deltas in Anthropocene. So before I introduce Robert, as usual, I would like to introduce our next webinar. Next webinar is this Friday. Remember, this Friday, we have another talk given by Professor Edgardo Lutubis, and he will talk about the large tropical rivers, particularly the rivers in South America, and specifically talk about the dam impact over the Amazon River Basin. That will be another very interesting talk. At the same time, please mark your calendar and come back this Friday. And also next week, we will have other two talks. Professor Hojie Wang from Ocean University of China, he will talk about the Yellow River derived sediment. And also Professor James Swisky from University of Colorado, he will talk about again another Anthropocene, the source to sink to the whole Earth system science. So it's a very nice overview talks next Wednesday and next Friday. Please do come back. So now Robert Nicholls. Robert got his degree from University of Southampton. As you can see later, he also returned there, become professor of coastal engineering. And since October 1st last year, he became the new director of the Tyndall Center for Climate Change Research. Robert is a world-leading scientist and engineer who studied the coastal problem and solution for 30 years. And particularly focused on how increases in sea level caused by climate change and result as coastal erosion and flooding, and how the community, the response adapted to these changes. So Robert is many authors. He wrote many reports for the government, particularly for like IPCC, we familiar with, and also he has published over 200 peer-reviewed papers and many book chapters. One thing I want to, for your attention, Robert was last year, 2019, he was named in the top 1% of the world's most highly cited scientists, researchers, 1%. So if you look at it today, his Google Scholar as a citation, as you can see, his citation is more than 46,000. Wow, that's really something. I think today here is the audience, many of us even not reached the 10,000 yet. But I also have a dream. Before I retired, I hope I can reach half of his citation. If my citation can reach 20,000, I will be hallelujah. So, but anyway, so as we said, we are very honored to get Robert to give us talk today. So Robert, now it's your turn. You can share your screen.
Right, where is it? Sorry, I've lost my, sorry, I've lost my PowerPoint. Where's that gone? Sorry, just a second.
No problem.
Is that coming through?
Yes.
Oh, okay, right. So I'm right at the end of it. Sorry, yeah. Right. Let me just get going. Okay, right. So is that good?
Good.
Fine. Thank you. Well, thank you very much indeed. It's a great pleasure to be invited here today to talk in this Source to Sink online talk series. I think I've listened to one or two talks already, and I've really enjoyed them very much. Today, I'm going to talk, I think, I'm probably not going to talk too much about source to sink. I'm going to talk, sediment's going to be featured in my talk, but I'm really going to focus on deltas as places where people live and what the future might hold for deltas as places for human beings to live. And in the context of the Anthropocene, and I think you all know what the Anthropocene is, but obviously at a time when really human agency now is as important as natural agency, or maybe even more important. And I think deltas really capture this issue of the Anthropocene and the dominance of human agency in what has happened and particularly what will happen in the future. I'm going to say a little bit about the background work that I'm drawing upon. Then I want to set a scene really of some sort of looking back over how this issue might have been thought about in the past. And then look at two particular projects, the Aspen Delta project and the DECKMAR project, and what's emerged from those. And then I'll sort of conclude. So first of all, just acknowledging that all this work obviously depends on a lot of different people contributing. And a lot of this work was done when I was at Southampton. And the Aspen Delta's consortium, ESPA is Ecosystem Services for Poverty Alleviation. That's what ESPA stands for. And we worked in coastal Bangladesh looking at the future of the ecosystem services and sort of livelihoods of people, with over 100 different people involved. So here's some of them at meetings, engagement with stakeholders in Bangladesh. The Bangladesh Planning Commission were a strategic partner in this. And we produced a book, which is open access. So again, in your own time, you can go and have a look at this, Ecosystem Services for Wellbeing in Deltas. We've also produced a book led by Professor Monsur Rahman in Bangladesh, which looks at actually applying the Aspen Delta methods to practical application within the Bangladesh Delta Plan. That's available for download as well. And I'd like to draw attention to this particular paper and Attila Lasar, who I worked with very closely over the last few years in terms of developing the integrated methods that we've used to look at deltas. And this paper has just been published, and I'm going to show one or two pictures from it. Then the DECKMAR project kind of followed on from the ESPA project, and it was looking at a slightly different question. It was looking at the issue about migration. As I'll say in a moment, there's a lot of discussion about migration, sea level rise, and deltas. And so we were examining the issue of migration and adaptation in deltas. We had, this was the University of Southampton, Bewit in Bangladesh, Jadavpur University in India, and the University of Ghana. And here are some of our meetings. Even more people, about 120 people were involved in DECKMAR, so it was a bigger sort of project than Aspen Deltas. And we produced, and we worked in the Volta, the Mahanadi, and the Ganges-Brahmaputra Delta, and we produced this book, Deltas in the Anthropocene, the title of the talk. So I'll draw on some of this at the end of the talk. So the issue of deltas and sea level rise and substance, I mean, this all kind of starts when it's going back really to work done in the 1980s, which sort of set the scene with both the Nile and the Ganges-Brahmaputra deltas were examined. And this was work was done by Jim Broadus and John Milliman, among others. So Milliman et al. 1989 in Ambio, still a very good paper to look at, even though it was written more than 30 years ago. And identifying these two regions as places which are low, and if sea level rises and we got plausible subsidence, huge numbers of people could be displaced. So this is the 2012, I've updated the numbers in the original paper to reflect 2012 population here. So up to 20 million people in Egypt were the numbers that they talked about, and 54 million people, that's about, that's getting on for a quarter of the population of Bangladesh being displaced by 2100. But this is, I think, and then this idea was then sort of taken forward by people like Ericsson, and this diagram was actually developed for the IPCC Fourth Assessment Report in 2007. Ericsson published this paper in 2006. and recognizing how many people might have to move if sea level rise continued as it was happening to 2050. So this is global sea level rise and the fact that deltas are also sinking. So you can see the hotspot of the Nile and the Ganges-Brahmaputra come in here. Extreme means more than 1 million people would have to move. And the Mekong also comes out as a hotspot, and then other deltas. And it brings out the point, global population especially in low and mid latitude deltas. I mean, there are high latitude deltas as well, but no people in them. So we are just talking about the low and mid latitude deltas with population. About 500 million people are living in these areas at very high concentrations. High population densities, maybe at least 7 times kind of the global mean population density, reflecting the high productivity and sort of wealth that delta environments provide. But when we think about these numbers, are they predictions or are they indicators? And I think they're clearly indicators of a problem rather than a forecast of what will happen, because these numbers here don't include any notion of adaptation, or any kind of human response to these threats, which one would expect would happen. So these numbers show you the scale of the problem, and if we take them literally, I mean, they are often reproduced quite literally. I downloaded this last night from the web. This is a sort of a picture produced by UNEP, which is kind of very much based on the Milliman et al. View of what will happen in Bangladesh with a sort of 1.5 meter rise in sea level, 17 million people in this case, 15% of the population being impacted, but it is treating Bangladesh a bit like it's made of concrete. So the war, all that's happening is people are living on the delta, water rises, they're impacted. And that, really isn't capturing what a delta is happening in a delta and what's happening under Anthropocene conditions. And again, teaching you all to suck eggs here, but if we look at the Bangladesh, we clearly have in a natural delta before any human beings were there, we've got the rivers producing sediment coming down the 2 big rivers, the Ganges and the Brahmaputra. So, and that's very seasonal with the monsoon. We've got cyclones and marine processes interacting with that sediment that's been delivered to the Bay of Bengal. And then as the sediment piles up, we have sedimentation, but we also have, this is on a plate boundary. So we've got tectonics, we've got substance, we've got a lot of natural processes going on shaping this delta. And then if we throw in human processes, we have global climate change, which will clearly mediate the catchments, it will mediate the Bay of Bengal, it will mediate what's happening in the delta. Sea level rise, but also temperature change will influence plant growth, CO2 concentration will influence plant growth, etc. There's lots of dimensions to this. But we've also got changes in the catchment, particularly dams and changes in the amount of water and sediment that might come down the rivers, a tendency probably for sediment to fall because of human action within the catchment. And the delta itself, we've got people and we've got an economy, and that's going to do an awful lot of things to the delta, including this issue of adaptation. And this picture here, which we developed within the Aspen Deltas project, kind of really captures the different scales. We have global issues like climate and sea level rise, but then the regional of the Ganges-Brahmaputra river basin or the Bay of Bengal, and then into the delta in itself, picking out things like river flow, the idea of embankments and polarization. There's over 100 polders in coastal Bangladesh, and then having effects on things like salinity, floods, substance, etc. And then in the reds, capturing the idea, well, there's a sort of governance, there's a set of rules and approaches to how people live in the delta, and there are the delta communities themselves, the people that are living on the delta and making their livelihoods. And these things are all sort of interacting. So it's actually quite a complex system when you start to think about what's going on in this delta, or in fact in any deltas. So the Aspen Deltas approach it was really to ask, what's the future of ecosystem services in coastal Bangladesh? This was a big project. I mean, there was a £40 million call came out And this was about 10% of that whole program. And we recognize that if you look for ecosystem services at the coast, deltas are where they are really concentrated. And so we wanted to look at the analysis of these services and human livelihoods in coastal Bangladesh. That's a very multidisciplinary question. So we're talking about social science, we're talking about physical and natural science, and engineering, and we're talking about sort of ecological dynamics as well. And really understanding all these different mechanisms that I showed in the previous picture and how they are sort of linked together. And so we had a lot of work working with stakeholders to develop scenarios and discuss results, and looking at the different processes that are going on, analyzing and quantifying these relationships, and then actually we produced a predictive model to explore these possible futures. And I think this point, making science available at the landscape scale for decision making, was kind of underpinned what we were doing. Our study area is shown here in coastal Bangladesh, west of the Padma. It's essentially the area that in the map, in the unit map, disappears with 1.5 meters rise in sea level. So it's that large coastal lowland that's is so near to present sea level rise, including the Sundarbans, the world's largest mangrove forest, or the part that's in Bangladesh. And how did we conceptualize the project? Well, the reds are showing you the kind of biophysical components across scales. So we start with climate, we go into the Bay of Bengal and the upstream basin, so climate's affecting those, and then into the delta plain, and then we move through agriculture, aquaculture, mangroves, the things that people are doing to make their livelihoods. And we actually had models and methods to be able to produce estimates for all these different components. In purple, and so in green, we looked at the socioeconomic dimensions as well. So we actually had household surveys to understand how people make their livings. We had demography, we had economic analysis. And purple covers sort of governance issues. And to actually integrate this, often the integration here is done almost by expert judgment, but that area that's shown with the green oval around it is where we actually joined them all together, and we used an integrated assessment framework to do this, the Delta Dynamic Integrated Emulator Model. And this is an interdisciplinary tool which covers, a range of different things, environments, the socio-economic dimension, demography, governance. It builds on our scientific understanding in what we call here high fidelity models, things like Delft 3D, secondary data, and this household survey, as well as expert knowledge from the team. And it develops a meta model that harmonizes scales and methods. It's coupled, fully coupled, and it's got a reasonably quick running time, so you can run it many times and look at different outcomes. And this is one sort of realization of the Delta DM approach. I don't propose to go through it here in detail, but just to note that there are blue boxes, red boxes, and white boxes. And so the blue boxes are where we have run a model to develop input. So we have essentially a data set from a model. Red is our scenarios that we've created. And then the white boxes are models, often statistical emulators, so we emulate maybe more sophisticated models to get faster run times, or process models. We also have an agricultural model where we're running the full agricultural model to look at productivity. And we have people, people are really important. We spent a lot of time talking to people in Bangladesh about this, so they had ownership and we understood how people in Bangladesh see things. So we had stakeholders in Bangladesh, we interviewed people, we had households, we had our expert team within the Aspen Delta's project. We had within the Aspen Delta's team a small group of integrators, and then we had users, essentially that was sort of Buick and the Planning Commission of Bangladesh, who are leading the Delta Plan. And the sort of way that we developed it was this sort of loop going from the stakeholders to the experts, the integrators, and then back to the users. And as we developed it, though, and the model we became confident in the model, you can start to sort of short circuit the expert team, and you can start just to run the model in more prognosis mode, which is what we did in the application work in one of the books that I just talked about. What are the inputs? Well, they're very diverse to reflect the different issues that are going on in the Delta in the Anthropocene. We've got climate, hydrology, what's happening in the Bay of Bengal, information on the levees and the polders, on the different ecosystem services themselves, like agriculture, the people, so the demography, how long they're going to live, what's the economy like, and how we actually, the governance, how we actually govern this area is also important. And what kinds of outputs can emerge? Well, we have outputs on the hydrology and the salt. Salinity was a really, came across, we had workshops, and salinity came across as a really big issue in Bangladesh from the stakeholders. We look at the livelihoods, and then we can look at household well-being and poverty. And we have both outputs at household level, which is the level at which we did our household survey, and we can aggregate these up to regional outputs. So we can look at how much agricultural productivity there is from the region. We can look at GDP per capita. We can look at sort of socioeconomic indicators at the regional scale. So there's a wealth of information here in the output. We actually constructed, this has just been published in +1, a household model called HEAP, which actually took the information from the household surveys and actually allowed us to take the agricultural and aquaculture and other sort of livelihood information and actually look at people's livelihoods and how they might evolve under different conditions and ultimately with sort of time. I mean, it's a big integrated model. So, I mean, there's a question about, do you believe it? So there's obviously the issue of verification and validation. So we certainly did a lot of work looking at sort of obviously debugging it. We compared the outputs versus the more detailed models. And we also did check it for, does the model actually sort of make sense? And we also looked at it, sort of independent data sets, things like information that the World Bank has on Bangladesh. We looked at, could we sort of get numbers that look similar to the World Bank's numbers? But this is a process that never really stops. It's very hard to validate integrated models. People aren't collecting the data that they would necessarily want. So it's an ongoing process, which I think in effect never really sort of stops. And to give you an example of a validation, here is in the black dots are some observed soil salinity measurements in a union within Bangladesh, and then the different colours are for different crops. So again, the salinity will depend on the crop you're growing. What salinity patterns does Delta DM simulate for that particular union? And you can see we're reproducing reproducing the seasonal pattern, and we're reproducing numbers that are reasonable. So again, we took this as a reasonable verification of the results. In terms of the process here, we said this is very much linked to what the people in Bangladesh. It's participatory, so we were really engaging with stakeholders and with the people who are doing the Bangladesh Delta plan as well, so the policy process. So we did follow this sort of loop here where we started with identifying specific issues in the white box, went into the grey boxes to develop scenarios of the future, which we used. We then felt that into the green triangle, which is Delta DM, produced outputs, and then we took them back to the stakeholders. So we had a number of cycles here where we discussed what we were doing, and we got reactions from people, and we moved from maybe what might happen to adaptations. What would you do about it? What? And then we were able to take back, well, if they did something, what would happen? We also developed scenarios over here on the left-hand side, and we had climate change scenarios, and we had the scenarios of development, which were developed across the project. And we were able to combine these in a sort of matrix. And we had several different ways of looking at scenarios, but this is one of the ways we looked at scenarios. To give you a feel for the kinds of scenarios we were considering, climate's clearly very important, but also things like agriculture, cropping patterns. What do people choose to grow? What's the land cover? We had river flow and nutrients. We ran the model called INCA to get these. We had information on fisheries. The Plymouth Marine Labs ran a model of the entire Bay of Bengal and actually computed fisheries based on climate and nutrients, economic growth scenarios, demography, etc. So there's a diversity of scenarios going in. Now I'd just like to show you quickly some just kind of one or two results that come out of it. So this is very illustrative. You can dig into the books and the material I showed you at the beginning if you're interested in this, and you can get a lot more material. And we're continuing to publish on this. I mean, we haven't finished publishing this. So, for example, one aspect we had is agricultural productivity. So here's the crop yield in 2050. What potential of the crops are we able to deliver? And the top panel, there's three scenarios across the top, and then at the bottom is the dry season. So red means you're getting much lower crop production, and it clearly varies between the scenarios as well. And in the dry season, you're seeing a lot less of the potential productivity because there's no water and salt, and there's too much salt. Really, so again, this makes perfect sense. And you can see the unit at which we're doing the simulations as well. So those irregular polygons are unions. So they're about 650 unions, sort of a political unit within Bangladesh, with about 25,000 people per union, and that was the scale at which we did the analysis. If we look at sort of aggregate views now, and we have, in this slightly different scenario framework here, we have a low sea level and a high sea level rise scenario, and we have a sort of a low development and a high development scenario. You can see that under low development, this is rice production over time. The rice production with low development, and it doesn't matter whether you're looking at low sea level rise or high sea level rise, is falling. If we look at the high development scenario, actually it's completely different, and you're seeing a large increase in rice production. The different colors are different strategies for managing the study area. So blue is protect, which is basically this area becomes like the Netherlands. We imagine very good dikes, well maintained, etc. So flooding really isn't a problem. We have unmanaged retreat, so really a sort of slow abandonment of the region, and when it's not viable to live there, people move, but it's not controlled by government. It's really at the household scale. People just give up when they can't live there anymore. But there is some maintenance of the polders, but it's not very good. Reactive relocation. This is a bit more active. If a union loses half its population, for example, it's abandoned. So we actually imagine sort of government having a bit of a drive here on actually encouraging people to move out, but not immediately, maybe when a sort of threshold is reached. And the fourth one is a bit more innovative. It's build elevation. So we're imagining what's called in Bangladesh tidal river management, or controlled sedimentation. So we use sedimentation to try and raise the land areas. And we have some data on that. So which we were able to compute how much we would be able to raise the land over time, and look at these different strategies. So they're quite similar, although actually if you note in the high sea level rise and the bottom panel, the purple is slightly higher than the others, but they're broadly similar. And one of the key things, by the way, with the high development is simply the consideration of new varieties of rice that are salt tolerant, which are being developed. So and these things are happening now. We can also look at population. Now, the population of the study area is about 14 million, and about 13 million of those are rural. And so we're just considering the rural population, and we can actually have rules that say when livelihoods fall below a certain level, people migrate. And so what you see is under all the scenarios and all the management approaches, people are leaving this area, and people are leaving this area today, where we see population. The population in this area is at fertility. Really, people are having about 2 kids per family, or a little bit more than 2 kids per family. And people are moving out. They're going to Dhaka. The population is falling today. And we see that under these sort of projections, things are going forward. We see this continuing. It varies from scenario to scenario. And under protect and build elevation, we see that maybe it's a little bit less, although again it varies that. And again, in the bottom high sea level rise, high development, the bottom corner there, purple, building elevation has a higher population than the others, so the livelihoods are better. And the livelihoods here could be failing due to things like it's not necessarily flooding, it's also drought and things like that as well. It's all aspects of climate change are being considered. And here you can actually look at, this is showing you a realization of the migration. So we have a migration model, which is explained in the paper. I've not time to really go into it here. But this is one realization of migration. We could, of course, actually take other climates and other sort of other ensembles of the future, and we could almost do a sort of PDF ultimately of what migration might be. But this is just one realization, and you can look at it again. So and you can debate the assumptions that are going into this migration model. I mean, that clearly can be debated as well. We can think about policy analysis with these kinds of analysis as well. So we can actually, one of the key ideas here was to try and be able to think, if we do something in Bangladesh, what is the benefit? And, and it can be a wide range of different things can be implemented. So the Faraka Treaty, which governs the distribution of water between India and Bangladesh, you can play with that. And so you have more water in the dry season to Bangladesh, for example, or less. There's the Ganges barrage. That's a structure that was proposed within Bangladesh. It's now been dropped as an idea. We can change polder heights. We can look at land zoning. We can think about subsidies for farmers. So soft things as well, guaranteed crop prices. So we can look at fishing as well. So there's lots of different things that can be looked at here. We really engage very well with the Bangladesh Delta Plan and the Planning Commission. This is Professor Alam, who is in charge of of GED, the General Economic Division of the Planning Commission, and led the Bangladesh Delta Plan. And that really helped to, I think, get some traction between us and the Bangladeshi stakeholders, that what we were doing was something that was serious and being taken seriously. And what did we learn? If we step back now, I'm just giving you a real overview here of a huge amount of work. Bangladesh to 2050. Well, I think the future is more sensitive to policy interventions and responses to them than climate change. That's quite an important observation, I think, because people often talk about climate change as being the big driver in these systems. And in our analysis, it's there. It's definitely not. It's definitely pushing things in an adverse direction. But the policy interventions and responses to 2050 were much more important. Now, that's climate change. Now, climate's jolly important in this region. So climate shocks, if you had a failure of the monsoon or a cyclone makes landfall, that can be a huge break on development. So, but I see that as climate variability. So, often cyclones get mapped to climate change. I mean, I don't see it that way because they've always had cyclones in Bangladesh. Of course, they may get more intense, and that would be climate change. So that's but I'm just saying, but cyclones are something to be of concern, and a major cyclone could be a catastrophe. Ecosystem services diminish as a proportion of the economy with time. So we see the other aspects of the economy in this area is transforming. We'll see a bit more about that in a moment. And significant poverty persists in some locations under all scenarios. If you don't address poverty, it doesn't go away by itself, according to our analyses. If we go beyond 2050, climate change becomes more of a concern, and it's not just sea level rise, it's higher temperatures that will affect crops, changing hydrology and runoff, sea level rise, and then, of course, this issue of more intense cyclones. That's something that really needs to be thought about. And if you really want to adapt to these changes, I think it's essential that you start doing it now. So climate is important, but I think in a sense of, and they're doing the Bangladesh Delta Plan, but that needs to be thinking through, what are you going to be doing in this future world? It takes time to set up the mechanisms that are needed to deal with it. And I think certainly this idea of building elevation, this controlled sedimentation approach, I think that's something, that innovation that should be explored more. They're doing it in Bangladesh at a small scale. I think, so be developing that maybe more at a larger scale. The issue of forested buffers, there's certainly a lot of interest in what happens if they put mangrove buffers along the southern coast of Bangladesh, and sort of maybe let the Sundarbans expand, maybe not as wide as the Sundarbans, but a small buffer along the coast. But I think we have to recognize that also people live there. I mean, there's tens of millions of people there, or it's 13 million. And so these measures aren't necessarily popular with the residents there. So you have to think about the sort of social dimensions. Are they acceptable to the people living there? So that's setting the scene. That was the Aspen Delta's project, and I think we learned a lot about Bangladesh. And then in DECKMAR, we sort of wanted to look more at some of these questions around migration and adaptation, and look more generally at sort of at deltas, and maybe thinking about deltas in the Anthropocene. We took the Ericsson map I showed you earlier, and we selected the Volta as a small delta in West Africa, about 850,000 people in the study area as we defined it, which is that red area there. It includes areas that really are upland, so it's the geopolitical units that are included in the delta. Then it looked at the Mahanadi Delta, which is the next delta to the Ganges-Brahmaputra, which is a medium-sized delta, substantially larger than the Volta, and about 8 million people. The Volta's got less than 1 million. And then lastly, the GBM, where we looked at Bangladesh and India, so a much larger study area. We took what Bangladesh see as the coastal zone as our definition. The delta, is obviously arguably much larger than this, but we had about 56 or 57 million people in the delta, so it's still a pretty big area of land. And so we had these sort of three contrasting settings. And of course, we had the political boundary between Bangladesh and India. So we had a West Bengal study area. We called it the Indian, the IBD, the Indian Bengal Delta, and and sort of the coastal zone of Bangladesh, what we did. And then we want to look at just three aspects that we were looking at within DECKMAR. And I think this possibly might be touched on more by Steve Darby and others when they speak, I think, later in this series. But the sediment supply by river, well, the Volta has had a historical sediment supply failure from the middle of the 20th century because, a large dam was put in, Lake Voltas. So the sediment supply to the Volta Delta essentially ceased more than 50 years ago. And so what's happening now is there's no new sediment supply from the river, and we have a delta plain that is being sort of reworked by marine processes. The Mahanadi Delta, we have a reduced sediment supply, and further falls are possible in the future. So, the sediment supply has declined. There's no guarantee that it will decline in the future, but it would look certainly possible. And lastly, the GBM Delta, again, the falling sediment supply, we can see that measured in some of the papers we published in DECKMAR, and further reductions look to be likely. So it raises the question, and I put the point about working with sediment earlier. Working with sediment approaches are not really viable in the Volta today, and potentially declining possibility in the Mahanadi and GBM deltas. So we have to really think about this when we think about managing deltas. I mean, Steve Darby often talks about sediment as brown gold, and so we need to think about how we use our brown gold, shall we say. A more social science aspect, demography and migration. All the deltas have active migration systems. Now, people are moving today. Dakar in 1950 had about 300,000 people living in it. Today, it's got 20 million people living in it. And it's, and that's continuing to expand. Calcutta was bigger, but Calcutta is growing similarly. So you've got two big cities in the GBM. And so this rural to urban migration is very, very active. And when we think about migration due to sea level rise potentially in deltas, sometimes there's a tendency to think everything's at equilibrium and sea level rises and people start moving. Well, we're talking about something that's happening now. The drivers of urbanization are general. It's the same as you find around the world. Economic, education, family, and rural to urban are pretty important. We did a huge survey. Environmental change factors are not seen as the primary driver of migration. They may be secondary to it, but they're not the first things that people say when you interview thousands of people. They don't. So that's, again, an important point. And I think the role of migration due to cyclones and shocks probably needs further investigation, because we were doing the surveys. There weren't cyclones around the time that we did the work. But in short, migration's complex. And even if environment, and climate change becomes a driver, it will be one dimension of a migration system. So we need to have a more sophisticated view when we think about people and migration in deltas. Also, the delta economy, I touched on this, we're talking about Aspen Deltas. All the deltas have important agricultural systems, and there's generally a growth in aquaculture. The GBM delta has seen, in both India and Bangladesh, has seen huge growth in aquaculture, and that aquaculture employs a lot less people, so that encourages migration to the cities because there's less work for the people that are in these areas. But the economy is rapidly restructuring. In the time I've been going to Bangladesh, I've seen huge changes. You can just sort of see that it's not necessarily equally distributed, but there's a lot more wealth there, and the economy is restructuring, and you have a growing services and manufacturing sectors. So agriculture is becoming less important in an economic sense. Obviously, it's fundamental to feed people. I'm not saying agriculture isn't important, but I'm just talking about the structure of the economy, and it's influencing what people do for their employment. So the 2020 economy is very different to the 1990 economy, and the 2050 economy is likely to be very different to the 2020 economy. And we've had COVID, so that we've definitely had another shock of a different type. But I don't think these fundamental trends are ultimately going to stop. Despite the sort of shock of COVID, for example. If we look at sort of key trends that we observe in the deltas more widely, sort of building on this, and these are all sort of summarized in the DECKMAR book, these tables in chapter 11, we can see a number of kind of key trends that we might maybe almost think of as maybe kind of what's going on in Anthropocene deltas. We can see threatened ecosystems. They're being pushed out, but by human pressures and climate change. Sediment starvation, I've already said that. Risks tend to be growing, and it's not just due to change in hazard. I mean, our exposure and vulnerability is also changing. We have growth in cities. The economies are changing, already mentioned that. We have growing needs for adaptation, and we have also beginnings of recognition that adaptation almost feeds back and influences how the delta evolves. All these polders that have been put in Bangladesh have stopped sedimentation. I mean, you all know this. But there are important choices. How we adapt will have a huge effect on the future of the delta. And we have the Bangladesh Delta Plan 2100. So we start to see visionary plans that are looking rather more strategically and further into the future, that have a capacity maybe for thinking about adaptation at these scales. We also, and if we think about this and try and distill this into maybe Anthropocene indicators in deltas, this issue of failing sediment supply, enhanced subsidence, intense land use, intensification of land use, and intensification of land management, and conflict maybe over land, agriculture versus aquaculture, for example. This issue of population migration, urbanization, economic growth, natural ecosystems just disappearing really or be declining, and this idea of delta level adaptation, maybe all indicators of the Anthropocene. And so just to try and draw together my thoughts here in the last sort of 5 minutes then, so I think deltas are hotspots in this Anthropocene transition, and we're talking about multiple and interacting social and environmental changes that are important here. I'm in the center on climate change, but it's not just climate change. It's a lot of other things that have to be considered with that. And if we look over the next 30 years, all the deltas that we consider in DECKMAR have the potential to develop in very positive ways for the residents. There's significant economic growth happening in Ghana, in Bangladesh, and in India. And so, I mean, these deltas could change economically substantially in their 30 years. And in that time, climate change, for example, isn't a particularly big threat, as I said, with Bangladesh. And certainly, if we get economic development, that means money, if if it's spent properly, there's lots of conditions in this. It can help to address challenges beyond 2050. So you create the resources to do things. I think certainly the idea of raising agricultural and natural areas for controlled sedimentation should be promoted where possible. So, I mean, I think, it may be declining as a possibility, but let's use it as much as we can. Let's maximize the amount of sediment coming down the rivers. But I say, and this point here, is sufficient sediment available? Is it socially acceptable? I mean, I think if people are growing crops and you want to flood their land for 6 or 7 months to raise it, what do they do in that time? So is there a compensation mechanism? You see, you have to think through the people living there. It's not just a technical question. And urban areas, we're not talking about raising DECKMAR with sedimentation. So in urban areas, well, we're back to traditional flood defense. So we still have areas that are losing elevation. And I think this raises an interesting question about the trade-off between elevation and wealth over time. Many people have advocated the need to build elevation, sort of, and to sort of undo many of the changes that have happened in deltas over time that have reduced sedimentation. But this point about elevation and wealth, if we look at the Netherlands, not one of the deltas we studied specifically, it's had lots of elevation over 1,000 years, much longer than, it's not really an Anthropocene process, it's maybe a precursor, but reflecting its high wealth, it's managed to deal with this with money, good access to technology, and it's innovating all the time, and it's got very good governance. I mean, if I was going to live below sea level, the Netherlands is a place I'd be quite happy to do so, because I think I would feel safe there. While the sort of long-term, I think the long-term health of deltas depends on sediment supply. I think wealthy societies in deltas can buy time. Economic growth increases the capacity of these options. So it may not be a solution forever, but we live in a world that's transient. So we can buy time, and then the question is how long, etc. But if we do look very long term, I mean, I've looked to 2100 years, we go beyond. I think there are 3 policy choices that are apparent for deltas in the face of sea level rise and subsidence. We can think of its retreat. We can just simply move inland. That's often what you see in newspapers. We can think about protection, a la the Netherlands, with ever higher defenses, including pumping, and residual risk. If you live in a low-lying area, New Orleans and Katrina showed us this, if the dikes fail or the levees fail, you get wet, and it's not very nice. It can be catastrophic. So I mean, you have to think about what happens when things don't go right if you follow that strategy, or building elevation via controlled sedimentation. We can also think about these together. We can. It's not then maybe not mutually exclusive. Maybe you can do. Building elevation probably means you're still going to probably end up having defenses. Maybe you need the defenses less. So, and I think there are certainly potential trajectories where deltas will prosper. I mean, when we look at the future, often it's kind of a bit negative about the future. And I think if we look at the choices we have, there's a potential for a good Anthropocene for deltas, but they require significant adaptation. And it's either working with nature to build elevation, more traditional approaches. We're talking about huge investments to be able to have this good future. So it's not going to come free. And then this idea of residual risk, depending on the strategy you follow, would need to be managed. And there are clearly trajectories where collapse may occur. So I mean, we can also see very bad futures for the Anthropocene, particularly where scenarios of degraded livelihoods and shocks from extreme events. So we can see quite bad futures. And I mean, I haven't got a crystal ball. I can just see the potentials for these and where we might be going. And of course, not all deltas will behave or respond in the same ways. So we may have successful and good Anthropocenes in some deltas, and in others we may have failure. So it's not going to be a universal response for all deltas around the world. It's going to be diverse and depending on the people that live there and how they manage it. So to conclude then, an overarching message, if you take 2 things out of this talk, other than maybe the materials you might look at in your own time, to understand populated deltas in the Anthropocene, I think we've got to consider the multiple and interacting pressures that are shaping deltas, and that includes environmental and human dimensions. The human dimension, the agency of humans is fundamental, I think, and the things that are done to protect the humans is fundamental to understand what has happened and where we're going. And there is not one future for deltas and human action, and choice has a huge control on what that future will be. Thank you very much.
Oh, this is fantastic. Thank you very much, Robert. Before we go to the question session, I have a quick question, Robert. So when you talk about the Anthropocene, what roughly the time scale we talk about? Because this word becomes so hot, so sexy. And of course, we know there's a very big controversial debate, but roughly here, when we talk about adaptation, our response, our social management, what roughly, time scale is 100 years or,
Oh, I would think it's something that's really happened primarily since World War II. In the book, we actually dodged trying to define when it was. I think we're just talking, I think the key point is human beings are becoming more and more important in shaping the future evolution of deltas. And so that's the key point. The moment when it happens will vary from delta to delta, if you think about it. Probably in the Netherlands, it happened much earlier. In the sense, the Netherlands maybe moved into the Anthropocene quite some time ago. Most deltas, I think it's basically a phenomenon since sort of World War II. But it's the construction of dams, it's the building of polders, etc. But many of the seeds of this have been there for a long time. So I think in some ways, from my perspective, it's not terribly useful to define when it happened. It's more to understand the nature of the process, and that key point that you have to understand a number of things going on and how they interact if you want to understand how we've got to today, and most importantly, where we might go in the future. So I think that to me, the insight doesn't actually need, timing isn't so important. It's just understanding the processes and taking a systems perspective. I think that's maybe another word I would say. Here we've taken an integrated assessment approach. We've taken a systems perspective of deltas to try and understand all the things that are going on.
Very good.
Often science is very sectoral and people focus on one thing and try and explain it with the one thing they know well. I think here you have to look across multiple things if you're going to really understand what's going on and the choices you have.
Very good. As most of people you can see from this webinar series, most of the majority of our talk is involving natural process, talk about how much sediment coming down, what the feet of sediment going, transport. And Robert, the talk, deal with the coastal management, adaptation, and also how we can keep the coastal resilience. This is exactly what we want. We need this understanding. Okay, now we have a question. Bill Mann, could you go ahead and ask a question? Bill?
Yes, I wondered if when you were talking about the immigration, you didn't mention the Rohingya crisis. Is that because that's resolved and Bangladesh isn't being as affected by that now?
Well, I suppose partly because of time, really. I was flying through a lot of material. That didn't happen in the time span of our study, so we didn't really study it. But clearly, it represents. No, it's not resolved. There are. I'm not even sure of numbers. There's a huge number of refugees sitting in the eastern part of the country. So that puts even more stress on this. But in the sense, I think it's not a. I think it's something that. It's an illustration of the issue. But I think what I said includes that. If you in broad terms, we didn't. It was pre that crisis that we were actually doing our work.
Right, and then I suppose the COVID crisis, which there's hotspots in both Bangladesh and in Western Ghana. So that's yet another factor that's going to have an impact not only on economy but on political policy.
Sure. I did mention that in my talk. I think I sort of see COVID. I don't know, do I? None of us know what the long-term implications. It's quite bizarre. At a personal level, I'm working in Norwich. I'm actually sitting 200 miles from Norwich on the Isle of Wight, and I've been sitting here for the last 6 months working at home. So, it's all these kind of changes that happen at a personal level. But back to your point, COVID I see as a shock that will probably that will not really affect these major socioeconomic processes. It might delay things, but I still think that if we come back in 2050, I would expect to see Dhaka bigger than today. I'd expect to see the Bangladesh economy bigger than today. Again, but I haven't got a crystal ball. But that's how I see COVID. And so I don't think it's going to be a fundamental change to these, but it's going to affect the rates of change that we're going to see over the next 2 or 3 years, and maybe longer. And of course, I might be wrong.
Okay, Robert, here's a question from Sonia Bint Mashad. And could you please explain what's the process of controlled sedimentation? Can you answer this briefly?
Yes, I mean, tidal river management is what the Bangladeshis call the top. And so basically speaking, within a polder, under the current circumstances, they have low areas in the center of some polders, which are often experiencing high water logging. So they allow in the monsoon, they allow flooding to happen, and then sedimentation of that, and so you build elevation, so it's really a response to water logging. It's on a fairly small scale. They don't really flood entire polders. They just flood the low areas of polders. And what we were modeling in simple terms was a rather more dramatic flooding, where I said this idea of how do you make this acceptable to the people who live there, who can't grow crops, and that's their livelihood for the period that's been flooded, is an important question. And there has been resistance to tidal river management from the people that live there because they don't necessarily get compensation. So there's a social dimension. I hope that explains it.
Okay, good. So we have 3 more questions. Michael Stickler, Jean Best, and Tom Bianchi. Okay, Michael.
Well, I was actually just answering the question about the tidal river management for Sonia. But one thing I was going to say that in some of your recent papers, you looked at the idea of building more polders in this sort of north central part of the delta, where the polders contributed to the problems of waterlogging. Do you think that that's still the best way to go, if you think that the natural sedimentation is the best way to compensate for what's going on?
Well, I think the issue with polders is I think you have to look at any intervention maybe in a more holistic way, Mike. The polders, the south central polders, I think the one area of our study area that isn't poldered is it's planned in the Bangladesh Delta plan to be poldered. And we did look at that with Delta DM, and we found that it had quite substantial benefits. And I think that's one of the issues with benefits over time. Polders in the short term do have significant benefits. Then, as you move forward, these waterlogging emerges not in the first season, but it emerges over the sort of decade timescale. And so that's when you want to think about some of these processes, maybe of tidal river management, for example, to maintain elevation within these polders so that you're managing waterlogging. So I think you want to think about it in a more holistic way. So, but I don't fundamentally think polders should not be built. And you found that from our work, I mean, there were substantial economic benefits. Yields went up very, very substantially with the polders. But of course, there may be others. I mean, we were really asked in that we were appraising a specific policy option, and we found, in the terms of the next 10 years, it seemed quite good. But you have to think about these things both in space and in time, I suppose. Yeah.
Right, and you have to management, because, for instance, in the Southwest, where they've been successful with some of the tidal river management, there are other places where the rivers have decayed and can't bring in enough sediments to compensate.
Well, sure. I mean, if you were going to do it on a large scale, you'd be talking about major sort of engineering to bring water, sediment-laden water in the monsoon into different areas, and so reactivating. And again, there are various proposals. The Bangladesh Delta Plan has an awful lot of different sort of projects. And I think the good thing about it is those projects were being thought of in the past completely separate, independently. Now it's trying to bring them together, so at least you start to think about how these things. It's a process, though. It takes time to learn, to be fair. I mean, but I think it's a great innovation that they are trying to think about things more holistically now.
Okay, good. James Best.
Hey Rob, thanks for a fascinating talk. You touched on this right at the end of your talk when you were speculating on the sort of changing diversification of Bangladesh's economy. And I know it's almost impossible to say, but I'm just wondering, in terms of the modelling forecast that you presented, how was that sort of factored in terms of diversification in the economy, growth in the economy, away from maybe even non-agricultural economy? Just wondering how that was built into the model scenarios that you showed.
Well, in Aspen Deltas, we actually really just simply use scenarios. So we just looked at trends. so that's nothing more sophisticated than projecting what had happened in the past. In DECKMAR, we actually had BC3, which is an economic research group in Bilbao in Spain, on the project, and they did produce computable general econ models of the Delta economy, which they nested into the into the Bangladesh national model. So they did somewhat more sophisticated modeling, and they came to the same sorts of conclusions. But it's still very much driven by the scenarios you put in, to be honest. I mean, I think this economic work is a bit of a dark art, really. I shouldn't be recorded saying that on a recording, but I think there are a lot of assumptions within those outcomes, and clearly I think a diversity of outcomes are possible, and I wouldn't think we captured all of them, but that the kind of preferred wisdom would be this continued growth.
Okay, and so with that, you said that online now in terms of the dark art, but in terms of a changing economy, in terms of more industrial growth rather than agricultural growth.
Well, it's happening. I mean, the economy, the agriculture now is not in economic terms. Agriculture is not the dominant activity. It's the dominant employer, but it's actually the other aspects of the economy are now larger now. You get into where you draw the boundaries, because many of the services are probably linked to agriculture, if you follow what I'm saying. So we're talking about, when they're measuring agriculture, they're talking about agricultural production, and there are clearly services that serve agricultural production, but those other areas are larger and are growing much more rapidly, and also offer better wages. So people tend to be, why are people moving? It's often because they can get a better salary or whatever, or better livelihood.
So those become a bigger driver. Thanks, Rob.
Okay, thank you. Tom Bearty, sorry for waiting. Tom.
Thank you, Paul. Thanks very much, Robert. I enjoyed your talk. One of the things I was curious about that I may have missed in your models is how important sort of the edification of the broader community is about sort of science issues and climate change and things like that, in terms of how money gets invested, in terms of how all the types of technology that you talk about are thought of as real solutions, because you have to have the buy-in. I mean, that's essentially what the Dutch have done for years. And so even if you have lots of money, I mean, you can see where this has gone awry just in less than 4 years in the United States. And so, how important does that fit into the models? Well,
it's not really part of the model. I think it's more the context in which you interpret the outputs. But I mean, we had stakeholder meetings. Bangladesh is a fairly most decisions seem to be made in Dhaka, really. And so we held workshops in Dhaka, and we'd have sometimes up to 100 different stakeholders from different parts of government and various NGOs. So NGOs that represented the regions that we were working in. I mean, people were pretty sophisticated, I think, about both the trends. I mean, I think we started off talking about where are we, and they were often saying, no, it's worse than that. I mean, they were very honest, shall we say, about where they were as a country, and we were discussing about where were you going and where would you want to go, the different sort of trajectories, and I think also they, I think all the things that we were proposing were felt to be feasible. I mean, the World Bank right now, for example, there's quite a bit of investment going into polder upgrade within the study area. I mean, I think it's like $1 billion has been spent over I'm not quite sure the period of time. In the polders don't look, all the dikes and levees don't look terribly good when you see many of them, to be honest with you. And they are going round and upgrading them in some kind of systematic manner. But some of the problems around waterlogging, and I think there are also problems that some of the technologies that have been employed there may have been employed in areas with less sediment, so they're not appropriate. So there's also learning and adaptation. I think the maintenance regime, probably they're quite good at doing capital. I think maintenance is probably, and we discussed this, where there's a weakness. And I think this was certainly when I discussed it with people, they all agreed and felt that's a priority. And I think if I look at the Netherlands, and also my own country, we're not a Delta, but I mean, but like thinking about the defences of London, an awful lot of attention goes on maintenance, and making sure that things are working well. And if they're not, getting something done about it. So that's kind of good governance. And I think it was agreed. So that's something that would need to be developed in all deltas. If you're going to, I mean, I think part of a good Anthropocene in all deltas is that good governance, really, and sort of, and it being an ongoing process rather than a big injection of money every 50 years and then you forget about it.
Thank you.
Okay, thank you, Robert. We have a last question from our friend in Colombia, Juan Kamala Ristropa. His question is, the population of Bangladesh has a serious short-term problem. I guess he means the increase in population sharply. So how to harmonize this concern with the problem associated with the rising sea level?
Population in
long-term scenario, increased population, rising sea level,
The population in Bangladesh is, people nowadays in Bangladesh have about 2 kids. So the population is, there's no growth in population because of large families. People are essentially replacing themselves. The population is growing because people are living longer. So I think the life expectancy has gone from 50 to 70. It's grown significantly. So I think the population issue in Bangladesh, in some senses, will just resolve itself with time, just like it has in places like Europe. I mean, that they're on a similar trajectory, but they're behind to where we are. So I don't, and our study area is losing people. So the population of that area we studied in Aspen Deltas is without doubt, people are migrating away. Can debate, are they environmental refugees due to sea level rise, or it's other factors based on our analysis in DECKMAR, it's other factors that are causing them to move. I mean, those are facts, really, and Dhaka. I mean, I did some other work in another project where we were looking at cities and flooding. This came out of Katrina in New Orleans, and we did a global analysis. And in our scenarios, we had 60 million people in Dhaka in 2070. Now, that's a very simple projection we used there. We had 60 million people odd in Calcutta as well. So these deltas may have absolutely huge cities in them. Not in my lifetime, but in the lifetime of my children.
Fantastic.
They're pretty big cities now, but I'm just saying they're cities bigger than anything we have on the planet today.
Good. Thank you, Robert. So as we next week, we have more, from Swisky, we will talk more that kind of Anthropocene from source to sink study, the whole Earth, not only the delta on the river, maybe also the ocean. So please do come in next week. But also this Friday, as I mentioned, we have other talk about South America, particularly the Amazon River Basin, the dam impact. So it will be very interesting. Please come back. So one thing I want to share on the social media, just a moment ago, somebody posted on this. Robert, you will be very happy. Somebody, just put your talk on the living room, the big screen. So also for the audience, if you have a Twitter account, you can follow us on the Twitter, Source to Think. You will get an update and every week the talk. So fantastic. Thank you, Robert. If you know any other question, so please, we can maybe stop here. So I'll see you Friday and I'll see you next week. So we have more wonderful talk coming up. Okay. So
thank you.
Sure. See you. So long. Okay, bye-bye.